we're here at the DevOps Talks conference, and Aaron, we've just had a talk from you. So first, can you introduce yourself for us?
Yeah, so my name is Aaron Bowden. I'm a customer engineer here with Google Cloud in Australia. I'm a customer engineer, so that is basically a pre-sale solution architect. So I go out there, work with different customers, understand their problems, and help them understand how to use GCP technology.
Awesome. And was this your first DevOps Talks conference?
It was. I had heard of the previous one in Melbourne through a colleague, and I was actually really excited for this one, so I made sure I was able to put something together that was able to speak to the engineers in the audience.
Absolutely, and it's always good to have a nice technical talk and really get into sort of the meat and potatoes, if you will, of the technology. And I thought it was really good that your talk also sort of blended two different technologies that are complementary to one another.
Yeah, I think that's one of the things. People sometimes think that public cloud providers are all about locking you in. It's actually, especially with GCP, it's really far from the truth. So there's a lot of open source technology and a lot of work that we're doing with other companies like HashiCorp, just making sure that you can use the right tool for the job, essentially. And you can see in the talk that I did today, I was using Terraform to orchestrate, and I was then also using HashiCorp Vault for the secret management, which was the main point.
Yeah, and as it was your first DevOps Talks conference, how did you find it?
I actually loved it. I really like the theme that's starting to come through DevOps is that it's not new anymore. People are actually going, all right, well, we can run this fast, but now how are we actually going to do things securely? How are you actually going to run a business? I think there were a couple of talks around there also not to forget the business impact of what we're doing, and I think that's actually really refreshing.
Yeah, so we can take some of the practices that have emerged and actually apply them to real business value.
Yeah, exactly right. So no point doing technology for technology's sake.
Right.
We'll all be out of jobs.
Yeah. All right, Aaron, thank you so much, and thanks
for
very presenting.
Much. Yeah, thank you very much.
Cheers.
Thanks.
So hi everybody, I'm Ron Crocker. I'm a distinguished engineer at Relic, the distinguished engineer at Relic. There used to be more, but they either got promoted or left. So I get to be the only one. So let's start with something important. This presentation and all, I'm going to read this to you. No, not really. They just make me put that in the slide. I'm going to start with a little bit of my background. About me, about New Relic, and my view. So, I'm a distinguished engineer at New Relic. Before New Relic, I worked at Motorola for 25 years building cellular base stations, which is decidedly not DevOps. Like, we were Agile. Like, I think I ran the very first large-scale Agile project ever. It's in the C2 Wiki, Warts Wiki, if you're old enough to know what that means. But our customers were the telephone companies, and they would have countries full of base stations, and we couldn't really deploy our software to them every day. In a good year, they might pick up a release. So, like DevOps really didn't apply. I moved to New Relic, and they are a DevOps shop. So everything I learned about DevOps, I had learned at New Relic. And most of that I learned from a couple of very important SREs there. So what is New Relic? Anybody familiar with New Relic? Somebody must be familiar with New Relic. So New Relic is this kind of SaaS, multi-tenant, huge collector of your monitoring data and analyzes your data and shows it to you. And a little bit about New Relic and scale. I said huge. Like, we get 40 million requests a minute, about not quite 2 billion data points every minute, and we query through 1,000 trillion. There's a word for the 1,000 trillion, right? I don't know what that is, but like many events get queried every minute. This chart, this kind of like pretty thing, that is the 10-year growth of traffic at New Relic. And as you see, it's kind of an exponential curve. We get about 4 to 5% month over month growth in this data. Like, growth is continuous at New Relic right now. And we hope that continues. So like, that's good for everybody, especially me, because I'm trying to buy a house and like I need the stock price to go up. So things, so we've got this huge amount of traffic coming in. We have an equally large system behind it that supports that. So if we've got 200 services, We run in containers largely. Some of the things are run kind of not containerized on bare metal. We've got 50 teams, 57 teams. I can't, it changes kind of slowly, but and 4 petabytes of storage. We run our own cloud, mostly because AWS is very expensive. I don't know. Anybody use AWS and like your bill? Like it's pricey. So we have moved all of this data through Kafka, and I don't really know how many machines we have in our data centers. We have 3 data centers in Chicago, connected as availability zones that process all of this, and some engineers on site, but then people in Portland that run it. Okay, I think I missed one. Let's go back. No, I didn't. I should have looked at the notes. It would tell you. So the first thing is New Relic couldn't exist without DevOps principles. That's my opinion. Like the way we build the system, we're constantly building, deploying, managing incidents, dealing with hardware failures, all that stuff. So we don't want to be a DevOps organization. I don't think anybody wants to be a DevOps organization because that's who cares? It's really about moving fast. We're DevOps because it's the best way we've found to move fast, safely. So that's why we do it. Is it going to work? Let's hope. Oh well, so much for technology. I'm an architect. I think about kind of the long-term view of the system. That's my responsibility. We have 50 teams that are constantly changing the system underneath, and my job is to influence them to do the right thing for the future of the company while still realizing that they have to ship. So sometimes I don't win. Like sometimes the 80% is good enough forces win, and they ship their 80% is good enough product. But often what I do is I come by afterwards and say that's kind of an 80% not awesome product. I understand you had to ship it. How about you make it robust? Other times, my job entails telling the rest of the organization to leave a team alone. Like they're doing good work, just give them some space. It'll come out okay. And I think that job complements the DevOps teams. And given what the panel had to say today, maybe this is a bit of a controversial statement. Not that DevOps is a team sport, but more that I don't know what it means to be a DevOps engineer or a DevOps team. We don't call them that, so maybe that's part of the thing. We have teams that are comprised of devs, dev-focused people and ops-focused people, and they work together and they own the things that they're responsible for. I think I've got some more on that in a minute here. So the dichotomy between dev tasks and ops tasks is pretty clear when we look at this kind of picture. I really wish this worked. Okay. So having a team full of SREs, if you're building customer-facing value, is probably not a great idea. Likewise, a team full of devs when you're building or you're managing a bunch of hardware is also probably not a great idea. But it does make a lot of sense to have a mix. And the mix can be biased depending on the amount of ops focus in your team or dev focus. Let me explain that a little bit. New Relic's organized into 3 teams. If you remember the picture I showed before with all that stuff, we sort of had those 3 layers. That's how we think of our system as well. Each of these teams has a vice president at the top of it, but realistically, those teams are a collection of small, autonomous, full ownership teams that include software engineers and SREs. They are responsible for everything. They are responsible for building the software. They're responsible for deploying the software. When PagerDuty calls, it's that team that gets paged. They own their own on-call rotations as well. And all of their process, and I'm going to talk a little bit more about that in terms of our project upscale. Teams are responsible for everything in their charter. and in exchange for that, the organization supports the teams in doing that. And finally, I think the last principle that I want to talk about is like embedding SREs in teams is the key. It's been the key for New Relic to be successful with DevOps. A dev-focused team really just doesn't have the skills. I know we just heard about T-shaped engineers. Like most of our devs are T-shaped but very narrow in the ops realm. And what the SREs bring is a focus on those kinds of things. All right, I'm going to switch a little bit to this project upscale. Has anybody heard about Project Upscale at New Relic? I can give a quick summary. We went through a huge upheaval in our organization about 2 years ago. And a lot of this is because our velocity just ground to zero. So we also kind of recognized that this was not something that your garden variety reorg was going to take care of. So the problem that we had is that we were growing very fast. Like this is a strange problem. Like, oh, I've got too much money. Like we were growing fast because we were being very successful, and like that's a great problem to have. It's like, but what happened is we were growing so fast that our organizational structure couldn't deal with the scale of the teams. Basically, when you scale out your organization, everything turns into friction. You've got a bunch more people that want things from every other team, and we ended up becoming very slow, very much not able to move forward. And what Project Upscale allowed us to do was kind of break through all of that. So the second problem, kind of correlated with the first one, is Conway's Law. Are people familiar with Conway's Law? Okay. So like Conway's Law, the simple version of that is that an organization is going to build software that kind of looks like the organization. In Conway's original paper, the example was if you got 4 groups and you're building a compiler, you're going to build a 4-stage compiler. Here's how Conway's Law played out for us. Don't laugh. I had to live with this. Each of the Post-it notes up there is a team. And each of those are little pieces of string, actually. Between the Post-it notes is a dependency that a team identified on another team. So teams don't really have dependencies on other teams. It's more that a thing that my team owns is dependent on a thing that your team owns. And you can see this really is the source of the grinding to the halt. It wasn't really the growing so much as it was like this layout of our software systems. And growing just made it visible. So Project Upscale is basically a reorg. Like, a bunch of vice presidents go into a room and a new org comes out, except that that's not what happened here at all. We started over completely. We hired a consultant. His name's Jim Shore. He's written some books in this realm. And we started to redesign our teams from the bottom up. Like one aspect that we had to deal with was that inter-team dependency. Like some of that inter-team dependency was accidental. Like a team happened to build a service, another team needed to use the service, and then we just created an inter-team dependency. We refactored all of our teams. This is kind of a 1 page of a 7-page spreadsheet that we handed out to everybody in the development organization, defining the new teams. And each of these teams has a manager and a product manager assigned, a lead engineer, or what we're calling a continuity engineer if it was an existing team, staffing levels, and kind of a first cut at a team charter. Mostly The team charter is mostly to give some guidance, general guidance to everybody about like, this team's going to be responsible for this. So we refactored the teams. We created new teams, we split teams, we shrank teams, we grew teams, we eliminated some teams. We do all the things that you would do when we do refactoring. And we also reassigned ownership of services. Like part of the reassignment was to deal with that kind of big ball of mud that we had before. Part of it was that like once you get these new teams in place, every service needs a home. So sometimes teams got things that really didn't make a lot of sense for them. In any case, 36 of these 46 teams were not staffed, basically, at the end of the refactoring process. And we had been telling everybody at New Relic that in a couple months we're going to be doing this thing where everybody has to pick a new team. Like your team isn't going to be here. This was very stress-inducing on the teams, frankly. People asked, we talked about it for months, and people asked every time we had a meeting about Project Upscale, like, tell me about self-selection, help me not be afraid. They didn't even say that, but it's like, help me not be afraid about self-selection. What if I don't have a seat? What if I get assigned to a team that I don't want to be part of? Can I sit at the cool kids table? You know, that kind of stuff. And really, it turned out that mostly it was self-induced anxiety. We went through a 2-day offsite. Everybody in the engineering organization, we have an office in Barcelona, we have an office in Phoenix, and office in San Francisco, and office in Portland. And everybody came to Portland. We got into this big room. We had a table for every team. Those big balloons that you see kind of floating up there. At the start of the day, they were down. So they were down, and when a team was fully staffed and felt they were able to be viable, they let their balloon go. So this is toward the end of the day. It was about, I don't know, 5 or 6 hours into the day that we were all done. All of the teams had been staffed. Of those 46 teams, or 36 that had to go through self-selection, only one of them didn't end up with people. And that was a very dysfunctional team. We did a little bit of, I don't know, encouragement and arm twisting and bribing, and we got people to join the team. So that's how we did it. That, 'cause, you know, sometimes you have to, sometimes there's carrots, sometimes there's sticks. You have to make things happen. It's a business. Like, these people work for New Relic. We didn't want to get rid of them, but we also needed to have our work done. The first thing teams did after they let their balloons go and have a big cheer is they started working on their team charter. The team charter was very important in this process because it was kind of the public-facing announcement of the job of this team. It sort of drew the boundaries of the team. So we're responsible for this and we're responsible for that. And we need to have this sort of makeup in order to do this job. The charters have to spell out kind of what a team owns so that teams can say no. I mean, realistically, the purpose of the charter was to allow a team to make choices about the work that they would work on and let the organization assign work that was appropriate. One of the things we tried to avoid, I think we did a pretty good job of it, was look at teams as pools of available people that could work on a really important business project. Even if it wasn't part of their charter, it's well, we need 5 Java engineers and that team over there has them and the thing they're working on isn't super important, so let's put them on this really important thing. And the charter actually allowed us to say no to that. The people, the product managers that run the company, pick priorities at least. They wanted to be able to do that, and the new organization kind of prevented that from happening. I think that was a win. So I said services got moved around too. Well, here's a brand new team. Here's a pile of services you've never done with. Here's PagerDuty. Have a nice day. that's not really going to work. Like, people don't know how the services work. They don't know what to do in an incident. So what we had was a 6-week service transfer period right after self-selection. So we did the self-selection. By the way, this whole period that we're working on this, our velocity is like nothing. It's kind of glacial. Service transfer, this 6-week hangover period, also kind of glacial in the velocity, but it was necessary. We needed to have the new team, the receiving team, be able to learn how to run and operate and understand the theory of operation, like what the thing does, in a safe sort of way. So the prior owners, so let's say you move from team A to team B, and some service from team A, is now on team B, or no, you're on team B. So you would stay owning those services from before for about 6 weeks, on call, everything about it. And then it was your job basically to teach the other people how to do that service so you could get off of on-call. That worked pretty well for us. One of the things we did in upscale is we told teams that they had autonomy about how they work. So there was no prescribing of, no, you have to use Emacs, because everybody should be using Emacs, right? In my opinion. You BI people can just leave. There's none of that. That's not the way we run. Teams are allowed to do whatever they need to do to get their jobs done. Some teams enjoyed mob programming. Other teams did more traditional pair programming. We let teams make technology choices. And all of that stuff works out really well for New Relic because you own your decisions. We told the teams that they were responsible for their choices. So if a team wants to mob program and that slows them down, but they feel like they get better full team ownership of stuff, that's fine, that's their choice. Nobody was going to push that onto them. Likewise, if a team, say team needs a database, we have a database team, everybody has a database team. We have a database team. They have a service that they call Megabase, which allows you to pretty much self-serve your own database instance, like RDB, but in our data center. They support Postgres and MySQL, and that's great. If you want a Postgres or MySQL database, you can go to the database team and they'll take care of it for you. If you want something else, like you want to run Cassandra or you want to run Redis, that's on you. You have to figure out how to do that. You got to get the hardware to make that happen. You get to operate it. You get to install it. Your freedom doesn't create responsibility on other teams. One thing that we did do, though, is that we made it incumbent on teams to help other teams make changes in their service. So the database team made it easy to do MySQL and Postgres, and enough requests came in for Redis that they actually made it easy to do Redis. But part of facilitated self-service is that you can't impose on another team's roadmap. You need something in their service, create a PR. It's nothing stopping you from writing PR. And we've told the receiving teams that when they got those PRs, that they were to review them as if they had built them themselves. So it's fair to be critical about how those PRs came in. What you couldn't do, and this is something I'll talk about in a few minutes, is what you couldn't do is say no to the PR and no, we're not going to do the work. You're basically blocking the organization at that point. And then you'll get a visit from someone like me or someone less friendly who will encourage you to get with the program. And the final thing I want to talk about with respect to Project Upscale, though, is some impositions on the product management people. So did I say project? Product management. So product management people pick what we work on. One of the key discoveries at the early stages of Upscale is a thing that caused a lot of pain and slowed the velocity down was churn. You're working on something and then next week you got to go this other direction, and then the next week you go back to where you were. Churn is another one of those things that just kills velocity. So we defined a process for this. We called it idea flow. Idea flow is where the features go, or the things that we work on. Feature is probably the wrong term. They go to the product council. The product council, I like to call it the Politburo, but like it's the executives. They sit in the room once a week to review progress, but they set priorities once a quarter, and they hold to it. This was an agreement that was hard won, really. We had to get the business to say, yes, we can be patient enough to wait a quarter to fix the priorities. And it was pretty challenging for them, frankly. But it was important. And then once those priorities are set, then what we had was what we were called swarming. So we've got these 50-ish teams. They know the priorities. We stack rank the priorities. Like there wasn't 7 number 1 priorities. There was 1. 1, 2, 3, 4, 5. Like if you're working on a priority 2 thing, but you could be working on priority 1 thing, then you should be working on priority 1 thing. And that's how our swarming works. This is a very simplified version of swarming. In scenario A, in the top one, there's 2 projects that have equal priority. The team splits their time between them. It takes 6 units of work to do it. They ship both of them at the end. It's great. In scenario B, though, they focus on project 1. They still spend 6 units of work, but they ship the first feature, then they ship the second feature. This is very cartoonish, and I apologize for that, but it was used as a means to motivate teams to stay focused. Stay focused, ship your product, move on to the next thing. So what's our experience been? We've been post-upscale here for about 2.5 years, give or take. It completely unlocked our velocity. This reorg, we're back to shipping kind of fast again. We were able to define a way to get rid of most of the kind of dud services. Everybody's got these. They're like the thing that everything funnels through. I have to tell this story because it's incredibly embarrassing, and it was done by people before me. So I don't have to take the blame. We have a service, like we first did our like microservice architecture thing where we took our monolith and started decomposing it. And we built these little services, but it was hard to build a service and deploy a service. So we grouped all these little services that were unrelated, other than they happened to ask questions of tables that happened to be in the same database, into this really perfectly named service called the interim service. And I'm not sure interim means what it still exists. The interim service still exists. It's 5 years after it was created. But we actually created a process by which the interim service is kind of withering through this service deprecation process. And the trick really basically is if your team is responsible for some capability that's in this service, and you probably have a service that's like this, like the junk drawer where you have all the miscellaneous kitchen utensils. Some team has to own it, because they have to own it and operate it and all that stuff, and nobody wants to. So what we did is we gave it to actually one of the best teams that we had, and we told them, like, oh, you don't want to own the interim service anymore? Like, get all your crap out of there, build a new service, and then once you're out, you hand it off to the next team. And so 2.5 years later, the interim service is kind of down to 2 teams worth of stuff. There was like 7 teams at the beginning. So we've been kind of slowly eating away at that. Idea flow really works for us. Like we've switched, what's the fad this month? OKRs, I guess. Yeah, so I don't even know what an OKR is. Like okay, whatever. So like we're doing OKRs now. Okay, and but the thing that Idea Flow does is it focuses us on stack ranking the work. So we have 5 OKRs that that the product council has said these are the 5 priorities for the organization this quarter, and they're ranked like this. And we've actually improved availability. I think somebody said it on the panel, like, you're doing DevOps right if like everything is getting better. So it feels like we're doing the right thing here. Like our velocity's getting better, availability's getting better. We're getting rid of the interim service. Like if I come back and get at this conference next year, I might be able to say it's dead. Like probably not, but I would like to. So I want to talk a little bit about the availability thing. This is a super busy chart. There's a lot of noise up here. This is basically like the last 4 years of how we deal with incidents and what processes we have. And I really want to just talk about 2 things on this chart, DRI and NERFs. So DRI is this thing that we call the don't repeat incidents policy. And what it does is if you have an incident, kind of a service SLI impacting incident, what we give you, like congratulations, you had an incident. Here's a little time box to fix the cause of that incident. Like you get up to 2 weeks. Most of them are like 3 or 4 days. Like super focused, fix the thing so it doesn't happen again. Because when they happen again, it's like, oh, if it happens once, it's once is an accident, twice is a trend. So, like, if it happens again, it's going to happen again. So, fix it. These little time boxes trump the product council priorities. Like, it's hard to prioritize some of these kind of lingering technical debt kinds of things. What we did is we created space for teams to be able to do that. This has helped our availability very directly. The other thing that we noticed, was that mean time to repair for incidents. We saw it more post upscale. Was creeping up, and it was creeping up because with the better organization of services and teams, what would end up happening is the on-call engineer would have to do 2 things. They would have to run the incident, and they'd also have to fix the problem. And support people are asking, hey, what's going on? VPs are like, what's going on? What's going on? What's going on? So what we found was, what we created was this kind of the New Relic Emergency Response Force. And they were people that were also on call all the time. There were 6 or 8 of them. They had a rotation. They would be on call for like 2 weeks at a time. And basically, they would get called in whenever an incident was of a certain severity level, and they would take over incident command. Like, it didn't really matter what product was having an incident, where the incident was. What they did is they became kind of project managers for the incident. So they're on site, they're doing all the operation stuff of the incident machinery, while the on-call engineers were busy doing the right thing, which is fixing the problem. This is cut, I think we've got some numbers on this. The numbers around 50% of the MTTR went away from these incidents when the nurse could be there. They were all kinds of people that were very experienced at running incidents, probably because they were like managers of teams that had a lot of incidents in the past. But they were very good at staying focused, getting the job done. So one last thing, it's not all super rosy. One area that's been particularly problematic has been this team autonomy. Teams hear autonomy and they think independence. I have freedom to make these choices. I have freedom to make all the choices. But that's not the case. We did not give teams freedom to choose what they worked on. We didn't give teams the freedom to say no to everything coming from expect inbound PRs, and they should treat them as if they came from their own team. They can't just say no. They can't say, no, we don't have time to look at your PR because we're working on this. We have a hero rotation typically, and that's the job that the hero would get. The person on call typically is a hero, and just does kind of these little chores as they come along. Okay, I don't have I'm going to skip that ops thing because I just don't have enough time. I didn't think I would, based on like practicing this. I want to talk a little bit about how like dev tasks can actually help with ops. And in particular, I want to talk about how it can help in scaling. So I get this little story about how New Relic's traffic, you saw the chart, like it was pretty low at the beginning and it grew over time and it grew over time and we ended up here, like pretty busy. And this is one portion of the traffic. So we have agents that we plug, if you're familiar with New Relic, there's language agents, we plug them into your Java apps or your .NET apps and they send us about 3 posts every minute with some monitoring data. 3 different classes of data, 3 posts, okay. And overall, that's about 8 million posts per minute. So 8 of the 40 are coming from here. The rest of them are largely, the rest of the other 32 are coming from our browser monitoring, mobile monitoring, and infrastructure monitoring. Yep, we need a little detour. Little, sorry, bad puns. Anybody familiar with Little's Law? No queuing theory people in the room? What kind of room is this? All right, so this is not super challenging math, but Little's Law is a very powerful tool if you're doing capacity planning. And basically it says queue length, or the number of things in your system on average, is the average arrival rate times the average service rate. So that'll tell you how many things you should expect. And really the power of this comes from being able to use average. So average is super easy to work with. And it'll tell you how many things you expect. If L is more than 1, then something's waiting. That L value includes things that are actually being worked on. So when L is more than 1, you've got queuing. Beats you need more stuff. So here's what our system looks like. We get 8 million things a minute. That's about 133 a millisecond on average. We measured the system that gets those HTTP posts. They do processing of 1 request in about 1/7 of a millisecond on average, which says that we've got an L of 18.5, of which that's more than 1. So what Little's Law doesn't account for straight up is horizontal scaling. So think of this as like single queue multi-server system. Like we have 22 servers, and conveniently L is less than 1 now when we horizontally scale. And that's great. So that's enough for Little's Law. So the product team wants to change the event reporting or event logging from once a minute to 12 a minute, every 5 seconds, basically. There's benefit to that to our customers. Like instead of things waiting up on average 30 seconds in the agent before we see them, they wait an average of 2.5 seconds. That has an alerting benefit. Like we have an alerting product, and that's important. But it's a lot of traffic. So suddenly we go from 3 posts per minute on average per agent to 14 posts per minute on average per agent, and we go from 8 million overall to 37. It's a lot. So if we go look at what Little's Law has to say, our arrival rate jumped to 617 per millisecond. We haven't changed our service time. We haven't changed the number of servers. And now we've got queuing. And just to give you a sense of what 3.89 looks like, that's kind of when you're oversubscribed and you got 3x queuing. So there's a couple ways you can fix that. The easiest way is basically with money. So you want to get back there? Just add 80 servers. There's nothing to it. Write a check. That's about $1 million, the prices of our servers. Write a check. Everything's fine. Oh, yeah, except that you've just added 5x the ops burden to that team. You didn't write a check for 5x the number of people to support that. You just created a huge operations burden. So let's go back and say, well, what else could we do? Well, what if we make it faster? What if we improve the service time? And this is just, a swag. What if we just cut it in half? Like, instead of taking a 1/7 of a millisecond, it takes a 14th. Like, that 3.89 goes down to 1.9, still queuing. But we don't have to add 80 servers now. We only have to add 29, right? So we've changed from 5x to 2x in terms of the ops burden on the team. That's much better. And that was a relatively small dev exercise. And if we want to not change the ops burden at all on that team, we have to go from 70 to 30, 0.07 to 0.03 mils. So like 30 micros to process a request. The team actually thinks they can do this. And they've got a couple tricks that I want to share with you. Like, tricks is the wrong term, but like approaches to take time out of the average request processing time. So this Vortex system is actually the system that I was just talking about with its 1/7 of a millisecond processing time. And it's pretty straightforward. Agents post their data, they send it with a license key. We have to look up the license key to figure out what account ID it goes with, because the rest of our system wants account ID. And then Vortex is a very simple, the reason it's so fast, I think 1/7 of a millisecond is pretty fast, processing a megabyte of data, is that it doesn't actually do anything. It like terminates an HTTP request, I'll do it this way, terminates an HTTP request, validates the license key, and sticks it into Kafka. Once it's in Kafka, it's safe. Like, while it's still in HTTP, we could lose the data. Once it hits Kafka, it's on disk, it's safe. So, it's the obvious thing. It's got a cache, kind of a read-through cache. We like these Guava loading caches, if you're familiar with that technology. Basically, you get a key, a cache miss. It's going to call out to some service to load the data, and then fill the cache and process the data. And when it's in the cache, it's all happy. So, like, great, we're decoupled from the database. It's got to say something nice. So that's as nice as I'm going to be able to be. Like, we're decoupled from the database, but we actually pass part of the load downstream. So as we go from 3 posts per minute to 14 posts per minute, we're going to see that hit that account service as well. We're coupled to the service. Like, the service is dead. This thing is dead. And the client's responsible for updating the caches. This is a thing that it really frustrates me about this pattern for caching. Like, the Vortex system has to understand the update rate model, all of the data model of that account data. Like, it doesn't really care. It just wants to be able to get a mapping from a license key to an account ID. So we have a different pattern that we like to use. We call it a data stream. And basically, that service, whatever that data service is, it has kind of a dual service rolled up next to it called the data stream, which kind of pulls the database, catches updates, and publishes them into Kafka. And then the clients, instead of talking to the data service, they just talk to Kafka. They're already dependent on Kafka. Like, all of our things are dependent on Kafka. So being dependent on Kafka, again, that's no big deal. We can load these in the background, and other clients can load it too, and it's kind of free. Like, we don't put any extra load on the data service or the stream emitters. Like, everything's kind of nice this way. And it has this really nice benefit that we can preload. So when we start up a Vortex, we can preload instead of having an empty cache where we kind of punish the account service. We have a preloaded cache, and everything hits the cache. So we take a lot of time out of the average service processing time. So, like, what we saw was that was about 30 micros on average, having a cache miss over all of that load. And we don't pass the load downstream, and the service is responsible for updating the data, and everything's so much better. So that's one model. The other model that we have is that we do a lot of this. This is an example of a thing that we do where we get data from the agents, and then we have to change it in some way. So what we do is we get data from the agents, and then we stamp on things like app name and host name and a couple other things. If you've used the New Relic product and looked at transaction events, they go through this system. And really, it's got to go look up information directly from the databases. Why directly from the databases? because we tried to build a service to put in between, and it wasn't fast enough. It was actually worse to have the service there then. And these data are sharded, so there's lots of databases, and DEC's had connections to all of them, and traffic had hit them all. And okay, so that's basic caching. So the first question you should ask is like, well, why didn't you put that in your fancy schmancy data stream? And like, this data isn't really appropriate for that. The keys are not stable enough. They're very dynamic, and it's a little challenging to delete data in a data stream. I'll put it that way. So the worst problem here, though, like whatever, is it took us 4 hours to deploy a change if we ever changed this thing. It would take 4 hours because we would deploy one, and they would put so much pressure on the databases for about 15 minutes as the cache warmed up that we couldn't actually deploy anything else that talked to those databases. And you had to babysit this thing, and there were 16 of them. So 16 of them, 15 minutes each, 4 hours. So we changed, what we've done here is we've changed the model. This is a pattern that colloquial I call like stop looking stuff up. So what we want to do is we want to get the sender to decorate the request with enough information that you don't have to. So we have a pattern where you make an initial request to cache something at the client, so it's very dynamic, but there's only one thing that has this. So it keeps track of its own token, and it sends it every time. All right, and we can just repeatedly do that. So, so the way we use that is that the agents connect to our system, we give them back their token, the agents send the token has the information that the decorator needs to stamp onto the data. It does so, it doesn't need cache. If it doesn't need cache, it doesn't need the databases, and this is so much better. Like, we ended up with, first of all, we have a standalone service with absolutely no dependencies, which is really very nice, other than Kafka. So, and we can deploy this fleet in seconds. We can scale it up, we can scale it down, we can do whatever we want. There's no impact anywhere else. I think the little beeping over there said I'm out of time. So it kind of works out nice. So let me summarize really quick. At Relic, like DevOps enables our teams to move fast. Project Upscale enabled New Relic to move fast, really. And don't forget about Dev in DevOps. That's all I've got.